Hello and welcome to Hocking College Lab 1102, Week 1, Day 2. We're going to talk a bit today about analytical chemistry and what it is, kind of broadly and in general terms. So let's start off with what is analytical chemistry? At this point, the book gives a slightly tongue-in-cheek definition of it's what analytical chemists do. To be a bit more precise, it is the science of improving analysis, more specifically chemical analysis. So developing new instruments and methods, handling new types of samples, things like that, pushing the boundaries of what we can analyze and how we can analyze things. Um, so they work on things like characterizing matter, so that can be qualitative, meaning descriptive, no numbers really. So yes or no, is it there, is it not there, is it blue, green, yellow, things like that. Descriptions, is it lighter than water or heavier than water? You know, and quantitatively, it's numbers. It is X% of the solution by weight is this compound. The density is 0.75, which yes does make it lighter than water, but it puts a number to that. So there's characterization, there's chemical analysis, there's also what the book calls foundational analysis, which is the work of pushing the boundaries of an analysis. And the other one, where did that go? Structural analysis. So what are the what is the structure of this chemical compound? Does it have an OH group hanging off of it to make it an alcohol? Is it an acid and has this structure on it? Things like that. So an analytical method has typically 7 stages. You conceive of the method, demonstrate that it works, prove that it's got the capability to do what you want it to. It gains acceptance. Other people start using it. You refine the method. Then you conceive of an improvement to the method, demonstrate that that's an improvement, establish that it works, and these are the capabilities. People start using the improvement. Then you go through and refine it, and you repeat it until at some point the method is no longer useful. Um, the book has a wonderful example of that. So we've got 2 methods here. These are from section 1.1 in your textbook. There are 2 methods here for determining the nickel content in ore. So you've got the old school method, and you look at the timeline here. It took 58 hours to do. You take the sample, soak it in a combination of sulfuric and nitric acid for 8 to 10 hours. Uh, some of it settles out as a solid, and that's going to be lead sulfide and sand, and you've got some other stuff that stays in solution. You bubble hydrogen sulfide through it, which, in case you didn't know, is kind of a rotten egg smell. It's the reason a lot of pulp mills stink, if you've ever been around a pulp mill. Um, so you do this at different points, different compounds turn solid and settle out, and you can measure the amount. And if you know the chemical reactions that produced it, you can come back to um, determining the amount of lead that, for example, that was in the original sample. And you go through until you've characterized it, and you know how much nickel there was. Um, the newer method is you take the sample, you heat it up in a combination of nitric and hydrochloric acid. Um, some of it stays in solids. That's not the part you're interested in, and you add some other chemicals, make sure that it's all nice and dissolved, and okay, I see. Add another chemical. Um, Add some until you get some solid coming out, and then you can weigh the salt, wash the solid off and weigh it, and figure out how much nickel you have. Um, a newer method would be to take your sample, dissolve it in an acid, and run it through an atomic absorption spectrophotometer and measure it probably within a couple hours at most. The thing is that your methods have gotten more time efficient as they've gone on. They've also gotten in the example of these two methods, they are the second method probably uses a lot less chemical as well, so it probably costs less. The method that's not shown on the chart here requires an expensive instrument, some compressed gases to run the flame in the instrument, and things like that. So depending on how often you do this, it may or may not be cheaper. And we'll talk about choosing an analysis method um, in a later class session. But something to think about in when you're thinking about methods. Sometimes an older method that might be a little slower makes more sense because you can do it with cheaper materials or instrumentation. So let's talk a little bit about an analytical approach. Um, it's basically a five-step approach for an analysis. What is the problem and what information do you need? You identify what you need to know. Um, Come up with your experimental procedure, you know, how to design the experiment to answer the problems you've defined. Conduct the experiment and gather data, analyze your data. Um, if it suits your results, um, propose it as a solution. Maybe discover a new problem. You might go straight into designing a new experiment. There's kind of two loops here. There's the smaller one and the larger one, and they can both happen. They can interact different ways. Check my notes and make sure I don't miss something I wanted to talk about. Right. So um, in the face-to-face portion, I will probably stop here and we can have a discussion about cannabis byproducts, byproducts in the cannabis industry, and what we might want to learn about them. Maybe talk about some of the problems with identifying those and what we need to know about them to do something useful with the byproducts. My wife's aunt and uncle bought into some form of cannabis farm in Colorado recently, and they called me a few weeks ago to see what I knew about possible byproducts. And I have to admit, I don't know a whole lot right now. I know that the big uses currently seem to be CBD and THC type products. I'm sure there's still a fiber market to some extent, and beyond that, I don't know. There's I'm not sure what's left of the plant outside of those. I don't know what the fiber market looks like, if that's worth selling into, um, or if you'd be better off selling it as biomass for somebody to burn to make energy or something like that. Um, I'm not familiar enough with the industry yet, but in that context, say we've got once we've extracted the CBD, um, if there's any, if there's a, harvested the portions of the plant that are useful for THC, um, maybe extracted the THC if that's something that's uh, useful. You've got the fibrous stalks, and that can be converted to fibers or not, or used as biomass. I'm not sure what else is left. That would be it, probably a problem. I'm guessing most of you are more familiar with than I am. Um, but whatever's left from that, what do you need to know about that to come up with something useful? Do you need to know maybe a rough idea of its chemical composition? Um, maybe try to identify some of the other compounds that might be in it. Maybe some of them are active and might have properties that the pharmaceutical industry might find interesting, or something like that. Um, so those are things that, as this industry matures, are probably going to come up. So you will probably find yourself going through parts of this process during that to come up with things to do with the byproducts. Um, yeah. Okay, so let's talk briefly about qualitative analysis, and this is the part of chapter 3. I skimmed over. I'm trying to cover mostly the highlights from the text. The sections are very brief. Um, Quantitative analysis is fairly self-descriptive. It's kind of what you think of the you know the CSIs drop something off in the lab. They run it through an instrument and they come back with a number. It is this much of that perfume. Um, so um, tried to I'm trying to highlight some of the ones you might not think about as much. So qualitative analysis. They do give an example in the textbook of screening an athlete's urine for steroids or performance enhancing drugs. You're just looking, is it there or is it not there? You're not after a number. You don't need to know the concentration. You just need to know if it's there or not. Um, your water quality E. coli tests work the same way. You you put some of the water sample on a plate, on a and put it in the incubator for a set amount of time and look at what grows, and is E. coli there or not is the real question. Um, and even the identifying the E. coli is somewhat qualitative. It E. coli colonies look like this, and the other bacteria look like this, and this other bacteria looks like this. So it's going by appearance. A lot of qualitative stuff can be taken a little bit farther, so you could, count the E. coli colonies, and count the other bacterial colonies and do something with those numbers. Um, you could, you know, measure the performance enhancing drug content in the urine, and come up with it is this many grams per liter of urine, um, and maybe try to estimate how long ago it was taken, or something like that. Um, so you can, a lot of qualitative methods you can take a step farther. Uh, Even the ones that are based on color, you can look at the color and measure the wavelength of that color and gain information from that. A lot of the spectrophotometric methods are based on that, really. Um, what is happening at a certain wavelength is, it's based on that. Okay, so the homework, there's a homework assignment uh, today. It's due uh, next Monday at the end by the end of class. It is the um, chapter one, problem one, numbers A through problem one, parts A through F. So the problems are in section 1-4. Let me bring this over to the screen that I'm recording. You see there's section 1-4 for problems. There's A through F. The discussion we're doing this week is based on problem two. So they for problem two, we wanted you to read an article called "When Machine Tastes Coffee," and instrumental approach to predict the sensory profile of espresso. Um, I don't have one with me today, but Monday evening during the live session, I had a cup of coffee with me that I drank, and I typically drink a fair amount of coffee a day, so I did have to go read the article's abstract, and basically it's somebody's come up with an idea to do some online analysis of coffee, specifically the flavor components, to so that you could adjust your coffee flavor as it was brewing. Program in some flavor profile you wanted, and it would adjust it. And I thought it would make a fun discussion to kind of think about what you might need to do that. What kind of broadly, what types of analysis would you be looking at? Are they going to be a little more qualitative, um, or a little more quantitative? Taste is an incredibly hard thing to put a number to. Uh, so that might lead you more towards qualitative. Then again, qualitative is really harder to automate in a lot of ways. Other than you can do a binary good bad type type approach maybe. But so I just want you to think about that. Put your thoughts down, and again, comment on two other people's things, preferably something meaningful, a little more than just agreement or disagreement, please. Um, put a little thought and time into it. Um, Maybe play with the idea a bit. Maybe instead of what else would you want to automate a coffee pot to do? If not adjust the flavor, would you maybe want it to automate? Maybe develop a system to automate the adding cream and sugar and have it adjust the amounts. That's a slightly different problem. Maybe there are other additives you want to think about. Um, just try to have some fun with it. I am a bit of a geek sometimes about random things like this, so I recognize that you all might not have as much fun with this idea as I do, but um, go ahead and try to. That's all I have for now. I'm you know trying to cover mostly the highlights from the text again, and things I think are important and might be relevant to your future careers, and hope it's useful. Um, Thank you, and good night.